Imagine looking into the depths of the universe and finding something that defies everything we thought we knew. Picture this: galaxies formed during the Dark Ages, when the cosmos is thought to be in its infancy. But now, thanks to the James Webb Space Telescope, JWST, we are seeing a revelation so groundbreaking that it challenges the foundations of cosmology. In this exciting journey, we explore how the 750 new galaxies discovered by JWST are shaking up the Big Bang Theory and making scientists wonder and panic. While scientific research investigated the origin of our universe, the predominant explanation was the Big Bang Theory. Countless studies and the collaboration of thousands of scientists have confirmed this theory, providing important evidence of how the universe came to be. However, today's scientific landscape is clearly different from the past. Advances in technology are constantly bringing new theories and perspectives, challenging what we previously thought were indisputable truths. In this evolving scientific environment, where new discoveries are changing our understanding of space, Neil deGrasse Tyson has become a prominent voice. Now, in a groundbreaking development, the James Webb Space Telescope, JWST, has made a revelation that casts doubt on the long-held Big Bang Theory. This discovery includes the identification of an astonishing 750 new galaxies, each challenging our previous expectations of what galaxies should be like. The James Webb Space Telescope was designed and built to help us understand the origins of galaxies, so we shouldn't be surprised that it leaves us scratching our heads. Join us as we explore how new JWST images debunk the Big Bang Theory by discovering 750 new galaxies. Scientists have put forward the Big Bang Theory as the main explanation for the origin of our vast universe. According to this theory, the universe was born about 14 billion years ago through some mysterious cosmic event, the ultimate birth story of the cosmos. The surprising nature of the James Webb Space Telescope's own images has challenged scientists' understanding of the origins of the universe. The hypothesis that these images directly contradict is the Big Bang hypothesis, which most cosmological theorists have long held to be indisputable truth. These galaxies appear to be too small, too smooth, too old, and too numerous compared to the expectations of the Big Bang hypothesis. The small size of the observed galaxies is completely at odds with the expected behavior of an expanding universe. According to the hypothesis, as the universe expands, objects should appear larger as the distance increases. At the beginning of the universe, all the building blocks of matter, energy, and space were compressed into a very small and highly concentrated point called a singularity. Within this singularity, matter and energy were compressed to such an extent that their density reached an infinitely high value. The concept of singularity comes from our current understanding of the laws of physics, specifically the equations of general relativity proposed by Albert Einstein. The expansion began with an extraordinarily rapid expansion known as cosmic inflation. During this phase, the universe expanded at an unimaginable rate, far exceeding the speed of light. Cosmic inflation played a huge role in shaping the large-scale structure of the universe. It smoothed out irregularities, homogenized the distribution of matter and energy, and laid the foundation for the subsequent formation of galaxies, stars, and other cosmic structures. As the universe continued to expand, the rate of expansion gradually slowed. Although the initial period of cosmic inflation has ended, the universe has continued to expand at a measurable rate. This continuous expansion is called the expansion of the universe or the cosmic expansion. Scientists have observed the effects of this expansion through various observations, such as the redshift of light from distant galaxies.
Redshift indicates that as the universe expands, light waves are stretched and shifted toward longer wavelengths, shifting them toward the red end of the spectrum. At first glance, JWST's images of new galaxies look absolutely stunning. You can see hundreds of galaxies in the same frame, and the sheer power of the photos cannot be ignored. But for scientists, things are quite the opposite. These pictures are surprising to say the least. They don't match what scientists thought they were seeing based on their theories. In fact, they see many more galaxies than expected, and those galaxies are surprisingly different. They are smooth, smaller than imagined, and really old. All these surprises are causing some panic among scientists. One article even starts with the word panic in the title, so you know things are serious. The ages of the observed galaxies seem incredibly strange. Here, JWST observations reveal the presence of galaxies that appear unexpectedly old. This calls into question the expected timeline for the formation and evolution of galaxies in the Big Bang theory. In addition, there is also the fact that the number of observed galaxies is much higher than it should be. The Big Bang hypothesis predicts the distribution and density of certain galaxies based on the expansion and evolution of the universe. But the JWST images show a huge number of galaxies, raising questions about the accuracy of the hypothesis predictions. There is also the fact that the flatness of these galaxies is completely unexpected. The Big Bang theory suggests that the structures of galaxies should be irregular and fluctuating due to the dynamics of their formation and evolution. But the JWST images reveal galaxies that appear unusually smooth and lack the expected complexity and roughness. During the expansion, we basically had all the stuff that makes up our universe squeezed into an incredibly small size. It was clear that matter could not survive in space like this, so something had to give. As the universe expanded and cooled, changes occurred. Particles such as protons, neutrons, and electrons began to interact with light and energy in their environment. These interactions played a key role in shaping the creation of matter in the universe in the first minutes after the Big Bang. A process called nucleosynthesis took place. This process involved the creation of light elements such as hydrogen and helium. The extreme temperatures and density of that phase allowed the fusion of protons and neutrons into the building blocks of those simple atoms. The synthesis of these elementary building blocks was an important milestone in the evolution of the universe. From a primordial sea of particles and energy, the early universe moved into a state where matter truly began to form. This process laid the foundation for the rich variety of matter and eventually the vast cosmic structures. Now, Big Bang theorists themselves expected to observe galaxies mixing and mingling with multiple collisions. But the images from JWST tell a different story. Instead of chaotic and fuzzy galaxies, the images reveal mainly smooth disks and well-organized spiral shapes similar to the galaxies we see in the universe today. This unexpected finding challenges the notion that mergers are a normal process in galactic evolution, as it is clear that these new galaxies did not go through any of the difficulties that you would normally expect if you followed the Big Bang theory. As astronomers carefully observed and mapped the cosmos, they discovered a striking pattern: clusters of galaxies and the general structure of the universe. Galaxies tend to group into large groups, clusters, and superclusters, forming complex networks that stretch across space. This observed large-scale structure is consistent with the predictions of the Big Bang theory. According to the theory, the universe began as incredibly dense and hot space and expanded and cooled over time. As the universe expanded, gravity played a key role in the distribution of matter and the formation of galaxies. The formation of galaxies and their distribution in the universe is consistent with the gravitational effects expected from an initial dense and expanding state as stated by the theory. The clustering of galaxies, the cosmic web-like structure, and the distribution of galaxy clusters support the idea that the universe evolved from an extremely dense initial state and expanded over billions of years. So when you look again at the sizes of galaxies found by the James Webb Space Telescope, you really see how the images represent a completely opposite reality to what we have always thought of as our reality. According to Big Bang theorists, these small galaxies grew through collisions and mergers into the larger galaxies we see today. To help you think about this hypothetical scenario, you can think of individual galaxies as a magical toy car, one that starts out as a centimeter-long vehicle but grows into a full-sized SUV when it collides with tons of other toy cars. But observations from the James Webb Space Telescope cast doubt on the proposed fusion process. If the toy car analogy is to be believed, one would expect at least some evidence of collisions in interacting galaxies. Is the Big Bang theory just a play on words? In fact, there is some compelling evidence to support this. First, you have things like observations of the redshift of light from distant galaxies, which provide evidence of the expansion of the universe. Second, the observation that galaxies are moving apart in all directions indicates that the universe is constantly expanding, as the theory predicts.